Hi, I'm an old guy and I do maths. Now here we have an interesting problem in that we're asked to complete the square for this function here. Now the first thing I'm going to do is I'm going to check that there is a real solution to this. So what I'm going to do is I'm going to take the discriminant of this and see what I get. Now the discriminant is b squared minus 4ac. For those of you who are at this point lost, have a look at either my video or someone else's video on the quadratic formula and discriminants. Anyway, a is the coefficient of x squared, b is the coefficient of x, in this case -6, which is a bit awkward given that my b's and 6's look the same, and c is 17. So let's just see what we get. So we get -6 squared, b squared, minus 4 times a, which is 1, times c, which is 17. So that's 36, and this is 7 fours are 28, and 4 ones are 4, so that is 68. We are looking at a negative number, and this is not encouraging. However, I am going to go on to complete the square. The negative number here, by the way, indicates that there are no real solutions for this. It doesn't mean that the graph of this, for instance, doesn't exist. What it means is that it doesn't touch the x-axis. Nevertheless, I'm going to go on and work this out. So here goes. First things first. X squared minus 6x, and I take half of this and I square it, so that's -3 squared, and I'm adding that to this. I'm going to move the 17 that was here over to this side of the equation, and because I added -3 all squared to this side, I'm going to do the same here. And what that gives me is, if I take this and write it as a perfect square, as in a factorized perfect square, I get x minus 3 all squared. Now, this would expand to x squared minus 6x plus 9. -3 times -3 is 9. And I would factorize that to x minus 3. So that's this side of the equation. And over here, I have -17 plus 9. Unencouraging, just like up here. So what do I get when I take the square root of all this? Well, I get x minus 3, the process being that we take the square root of each side, plus or minus the square root of -8. Now, there are several warning signs. We already know that this side of the equation is going to be negative. We've checked the discriminant, it's going to be negative. What do we do about this? Oh, well, first of all, we put in an equal sign. I'm sorry, I forgot that. That's what this should look like. And then what we can do is we can say that x equals -3 plus or minus the square root of positive 3, sorry. X equals +3 plus or minus the square root of -8. Now, many of you will have been told that you can't find the square root of a negative number. I'm going to brush aside a whole pile of explanations and just say that the square root of a negative number is a complex number. And a complex number is made up of a numeral and the letter I, which is the imaginary number. So at this point, those of you who are sort of uninterested in continuing can simply look at this and say that there are no real solutions. And in fact, there are no real solutions. What we're going to come up with is we're going to come up with a solution that isn't real. And that solution looks like this. X equals 3 plus or minus the square root of 8, and there's our imaginary number there. And we can further simplify this. X equals 3 plus or minus 2 root 2i. No real solutions. These roots are unreal, and if you were to graph this this function, what you would see is that it's floating somewhere in space. It does pass through the y-axis at 17, but it does not touch or pass through the x-axis. So thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.